Hey everyone, and welcome to the SaaS developer community where we learn from each other how to build software as a service. And with me today, I have Krishna, who is a technical leader at DeltaStreams, and he built the DeltaStreams software as a service platform. So we're here to learn what it does and what we can learn from him. Welcome to the show, Krishna.
Thanks, Gwen.
Okay, so Krishna, you've spent the last 2 years building the software as a service platform at DeltaStream. Can you tell us a bit about what you did before that and how it kind of helped you prepare for your current role?
Yeah, so I started out working at a couple of small companies, but eventually ended up at Red Hat for a while. And this Red Hat acquired one of the startups I was at named Makara. And Makara, we were building a platform as a service, right? So it was a platform as a service where you could launch Java applications.
That's useful.
Run, right?
When was that?
So this was early 2010s, I want to say.
Oh, that was way before its time. Amazing. Real pioneering.
Yeah. So Red Hat was also building a PaaS internally, right? And they acquired Makara, and basically we joined efforts and we started on OpenShift. And this was a platform of service before Docker, right? Before any of those tools were available. But the kernel still had all of the capabilities to actually isolate things. So it had user namespaces and network namespaces, like all of the core pieces of the kernel that you can use to isolate workloads. So I worked with a really amazing team at Red Hat to actually build this out. And that became OpenShift, right? Then Docker came about. Docker came on the scene and became super popular, made containers very easy to use. And we started to incorporate Docker into OpenShift. Eventually, OpenShift actually moved on to using Kubernetes. After Red Hat, I joined another startup named StrongLoop. And StrongLoop's core mission was around Node.js. So make Node.js easy to use, build DevOps toolkits around Node.js to allow for better debuggability, better traceability, allow it to run. And at StrongLoop, I also developed a platform to let Node.js applications based on Loopback, which was our API framework, run on both Docker as well as Kubernetes-based workloads. StrongLoop eventually got acquired by IBM. Actually, it seems like everything got acquired by IBM. So StrongLoop got acquired by IBM, and I joined a product at IBM called API Connect, which was an API gateway, right? And at for the API Connect product, I was basically the lead of the platform team over there as well. And we used Kubernetes and Docker to package up API Connect and make it deliverable on quite a few different platforms. So we had a SaaS service for it. We had it running on both OpenShift clusters and vanilla Kubernetes clusters. And we also had it packaged up as a VMware application. So we had VMware, which internally would self-bootstrap Kubernetes, and that was challenging, but it was fun. Right. So eventually after that, I joined DeltaStream. Hojat was actually the founder of DeltaStream, was my colleague at UC Irvine when I was working on my PhD, and so was he. So that's how we know each other.
So you worked in the same lab in UC Irvine. And
we did, yeah.
And then your careers took very different passes.
Yeah.
And then you decided to combine both sides, the platform side and the stream side.
Streaming side, yeah. So he brought all of the streaming experience, and I brought some of my platform experience with me, and we used that to build DeltaStream.
Amazing. And all your background with OpenShift, like being there from the very beginning and using it to build kind of a platform for APIs and all that, like it's just such a perfect fit.
Right.
But I'm ahead of myself. You have to tell the listeners what is DeltaStream so they will be able to appreciate how perfect it all is.
Yeah, so DeltaStream is a serverless cloud-native stream processing platform. That's quite a bit of words, but essentially what it means is that you can type in SQL, right? And we will accept that SQL and we will launch that query as a streaming query where it can read from stores like Kafka, Kinesis, right back to do some processing on that, filtering, grouping, aggregation, subqueries, like all of that stuff, and then write it back into those streaming stores. Right, so that's read from something, do some processing, right back into streaming. You can also work with materialized stores. So we have a managed materialized view, but you can also write out to say Databricks or Snowflake based stores as well. And all of this is built to be serverless, right? And that's actually one of the key things I'd like to point out is, in a typical store, like say you're running Flink on AWS, you have to start by defining your cluster. As soon as you do that, now you run to certain questions like how big should my cluster be? How many queries am I going to be running? Now, all of that planning has to be done up front because changing it later is annoying at least, right? And it can be difficult. But as soon as you go serverless, you don't have to worry about that as much. Limited resources doesn't really become a problem because as you launch more queries, you get the resource and you can use it. The other thing is, as soon as you have a cluster, the isolation of the queries within the cluster becomes harder to do. You are basically running within the same processes, sharing the same memory. If something has an error, are you really sure that none of your other queries are affected? Right. So one of the other points that serverless helps with is like all of these queries are essentially isolated. They are very isolated from each other. A failure in one doesn't affect the other.
And this also
Resource usage in one doesn't affect the other.
Yeah. So this also
Right?
makes the platform a bit more secure. There couldn't
It does, absolutely. Yeah, since it is isolated, we can apply much better security constraints around it and make sure that so even if you have workloads from two teams running within this platform, if there is an intrusion on one of them, it doesn't affect the other. You have that isolation. And it also helps with scale because, again, each query can scale independently. You don't have to scale the whole cluster and then hope that your queries fit in properly.
Yeah, so it sounds like basically the value of serverless, when you say that we're serverless cloud native stream processing platform, the value of serverless is around the developer experience. Developer can focus on their queries, not worry about a lot of details that they otherwise would have to worry about, which is something I'm a huge believer in general. So can you share a bit about how those things kind of work in practice? It's just, developer logs into a platform. Do I just start typing queries and I'm good to go?
Very close. Very close. So basically, you log into DeltaStream and you land on a page where you have to start out by defining whom are you going to be talking to. So where is your Kafka store? Where is your Kinesis store? You define that and you basically provide all of connection details. Right? And connection details in case of Kafka or Kinesis, if you're running within AWS, can also just be IAM credentials. So we support both stores that you're running yourself with, say, username, password kind of things, or all the way up to limiting it to particular IAM roles within AWS. Okay, so you have your store set up, and that basically sets up your connectivity. Right? The next thing you have to do is define a database. And once you have a database, it comes with a public schema, and you can run your first SQL statement, which would define a stream on top of one of the topics within Kafka or Kinesis. So stream is just metadata. You can think of the Kafka topic as a file, right, on your file system. And then you can think of the stream with the metadata defining what columns and stuff are there as a table within a database, right? So it looks very similar to, let's say you're running a Postgres database and you can list all of your tables there. In DeltaStream, you can list all of the streams and change logs and other relations. So the next thing you do is you run a SQL statement to launch your query. So you would essentially say create stream as select star from the first stream. And that will launch a query in the background running Flink, right? That will read from the topic of the source stream, do whatever processing you want, and write to the topic of the destination stream. And that is the simplest query that you can run. It is also a very useful query that you can run because you can do filtering and aggregation and grouping all in one over there.
So from this entire flow, it sounds like the platformy part is obviously when you connect to a Kafka, because you need somehow to manage how to connect to this Kafka, and
right.
It seems like all the way down to the processes that will eventually run. The defining the metadata seems like it just saves it in a database somewhere, maybe?
It does, but that is where we can apply RBAC rules. Right?
Oh.
So now that you have a database,
when I define a stream, I can actually say these groups of queries can get access by those users.
Right. So you can have users within the organization. They are granted roles. And this RBAC is very similar to RBAC you would see in Postgres or in Snowflake. Users are granted roles. Roles have privileges on stores. They have privileges on the database and on the streams that are defined. And using this, we can have very fine-grained RBAC rules that you can use to, even within the organization, define who has access to what pieces of information.
Makes sense. And these rules also have to be propagated all the way to at least a Kubernetes integrated authorization layer of sorts.
Right.
And then obviously when you run the query, that's where it's kind of the most magical because you have to manage all those processing.
Right. So, once you have all of these relations set up, you have the store set up, your query, someone has typed in the SQL statement saying, launch this query for me. So that's when the more interesting platformy side stuff happens, right? So we take that SQL query, we make sure that all of the RBAC rules are validated. Everything is good to go. We build the Flink job definition. And at that point, the data plane can pull that job definition over, launch a query in an isolated cluster, right? And then essentially run the queries over there. And as this is happening, all of the status updates and metrics and that sort of data is being pushed back by the data plane back to the control plane, which is where the user can log in and see what's going on. Like, how is the query operating? If there are things that happen, so let's say something causes the query to fail, and you have to trust that something will cause the query to fail at some point, right? Faults happen. It could be bad data came in. It could be that there was something in the logic or a UDF that caused a failure to happen. We actually will monitor the query constantly. And if anything does happen, we try to isolate the problem, relaunch the query if possible. If not, we notify the user, hey, something's up, come take a look. So that they can then take a look and then relaunch the query after they have fixed the situation.
Yeah, one of the issues that I repeatedly ran into on data warehouse scenarios and big data scenarios, I think it may also apply in your case, although I'm not 100% sure. You run a query, it's actually running in data warehouses. It can run for a really long time. It ran for 3 hours out of a 6-hour report, and then it failed. And I look at it, I find the stupid bug in somewhere that I forgot to filter something, and this caused me to run out of temp disk space. I fix it, and now I have to start a 6-hour process again.
Yeah, so that is the problem with batch processing, right? Stream processing is different. So in stream processing, as we are progressing, and Flink actually does a fantastic job of this. So as you're progressing, Flink is constantly taking checkpoints and snapshots of what's going on, and it's maintaining a position within the stream that it has processed to. So if there is a problem like that, where there is bad data that you have to fix, or you have to, munch something somewhere, if the query fails, you can get the position of where it left off and use that to launch a new query.
Nice.
So that
amazing.
That is very useful. So that way you don't have to relaunch your 6-hour batch query. Having this continuous processing helps with that. And
so I'm just saying, now you added Flink to the mix. So it just looks like we have a lot of moving pieces. Can you connect the dots for us a bit? I typed the query and clicked run. Can you share a bit of the secret sauce? What does it do?
To some extent. So when you type in the query and click run, we process that query on the control plane side. We then pass that job over to Flink. So Flink now is running a cluster just for that query. It's an isolated Flink cluster. But before that happens, when it gets to the data plane, we actually have an operator that we have. An operator is a Kubernetes concept. So essentially, in Kubernetes, you can define certain resources that the operator can watch, and based on those resources, it will do something, right? So
you have a
in our
Flink
case,
operator that is maintaining this Flink, the cluster of Flink workers, I guess, essentially.
Yeah, so it's the Flink operator. It's his DeltaStream Flink operator. It gets a hold of that job from the control plane. It then launches the Flink cluster and launches the job within that cluster, and then monitors the job for status. Right. So if an error is encountered, the Flink operator can then take a look at what that error was and then report that information back. So that is a very high level view of what is
What
happening.
made you decide to write your own Flink operator?
So we actually started out with looking at the open source one. Right? Yeah. It is a very good operator, but we needed to then go beyond what it is capable of doing. So we wanted to have our own logic around, how we scale and how we move things around and where we run the cluster. So some of that the open source one is capable of, but it wasn't back then when we launched. So we wanted to basically build our own that will allow us the flexibility and the capability of like iterating and moving faster than the open source one would have allowed us to. So because of that, we ended up writing our own operator around this.
So you came from very strong, obviously, Kubernetes background. You obviously knew all about writing operators, but you probably didn't have a lot of Flink experience. How much Flink do you have to learn in order to write an operator?
Luckily, Hojat had a lot of that experience. So we have other team members who are experts around how do you run Flink, how do you run things in Flink and have it be efficient and give us signals so that we can use those signals to scale. Right? So the other team members on the team actually helped the platform side decide how do we want to launch Flink and do that in an optimal manner. And it's a collaboration. So there's between the team that is building all of the Flink level things and the team that is building the platform side of things. We have to collaborate and figure out what are the signals going back and forth so that we can actually use that information and run the product better.
So the thing everyone always says about Kubernetes is that it's a platform for building platforms. And I always had this problem that it still felt extremely leaky for me. Like if I'm running Kafka on Kubernetes with the best operators out there, I still need to know a lot of Kubernetes to actually run it. And it seems like you were actually successful in building a platform on top of Kubernetes that allows the user to not, as you said, write a query, not worry about everything going on behind the scenes. So I'm wondering if there's any like insights into here is how to do better as you are writing your own platform.
We are always building on stuff that's out there. A lot of people and a lot of work has gone into just making Kubernetes better over time. And there's actually a foundation called the Cloud Native Computing Foundation, CNCF, that has documented a ton of tools that you can use to, make your life on Kubernetes better. But I can mention a couple of them. So
yeah, I was just thinking because I was looking into it. The list is honestly endless. Is there like top 5 that I can start with?
Yeah, it is ginormous. So the easy ones, right? So for certificate manager, cert manager, the name has it in there. So it is very useful for any place where you need to issue public certificates or even internally maintain certificates of any sort. For scaling, we started out with the Kube autoscaler, but AWS actually has a version of it called Carpenter. Not a version, but an independent project called Carpenter that lets you scale out your Kube cluster based on workloads. Yeah, so that helps with just making sure that you have enough nodes to actually run the Flink clusters that need to be spun up. As far as deployment of all of our microservices, we ended up, so we evaluated Argo CD and Flux CD, and we settled on Flux. It was a bit simpler to work with, and it basically suits our purpose over there. We have a bunch of policies that need to be maintained. So we have, security policies, image policies, and stuff like that. You can use either Kyverno or OPA. OPA takes a bit more work. Kyverno might be a bit simpler to set up initially, but OPA is like very flexible in what it can do. And networking, which is I think one of the very important layers. We started out using a combination of Calico and Istio, but then ended up transitioning over to Cillium. Right, so, and in networking, again, network policies are super important to make sure that all of your services can only talk to the services that they're supposed to. Right? So that it builds on the concepts of zero trust. So you want to verify and limit access to what you have. So, that applies to both services talking to other services within your cluster, but also egress. So whenever we have a Flink cluster that needs to talk to, say, Kafka, we want to make sure that we limit it to just that one Kafka, and it can't talk to any Kafka in the world.
Yeah. So is that something you do via network policies?
We do, right. So Cillium actually has very powerful network policies that let you build out some of the stuff. And this is another place where, the open source operator doesn't really have all of the capabilities. So if you want to launch a Flink cluster and limit it in a lot of ways, then we ended up building our own operator to apply some of these constraints around the workloads that we run to make sure that that workload is truly isolated and can only access the things it's supposed to.
Yeah, absolutely. So basically, if I spin up my own cluster, then there's network rules that make sure that nothing in there can talk to anyone except the things that I told it to talk to.
Right.
If it's, I think you mentioned serverless is a shared cluster, if I understood you correctly, and then you rely more on RBAC to make sure that you limit who.
So you have a choice. Right? You can run on the public platform, which is a shared cluster. But if you want to limit access to your data such that you don't want it to leave your VPC or your network, we also have bring your own cloud version of it. So essentially there, we run the data plane right next to your VPC. And that way we can limit the data plane to only have access or only allow access to anyone within the same boundary, your network boundary, right? So no data actually leaves unless you specifically allow it to.
So is it like bring your own account kind of thing? Your platform actually runs in the customer account?
It does, yeah. So we have the public one, which runs within the DeltaStream side of things, but we also have the other option where the customer brings their account and we spin up everything there and we isolate it to talk to just within their cluster. So the data never leaves their account.
So I know that from the SaaS developer community, there is growing demand I want the vendor to run stuff in my account. Like I want to see the machines. I want it to use my discounts kind of thing. But from a lot of, especially like early stage, which both of us are kind of still are, it's really scary because how do you debug problems on your platform on someone else's account? So do you have tips for people who are scared? Are we right to be scared, or is it actually easier than we think and we should all go and try it?
No, this is a tricky problem. We haven't quite figured that one out ourselves, right? So this is probably going to take a bit more time to figure out the best way. And we will be watching the SaaS community and learning from them as well to figure out what the best approach is here. We have some ideas around this, but nothing really set in stone yet.
Yeah, I think this is very normal. One thing I know that I learned from the community is that asking the customer to have like a role, you always need a role in their account.
Yeah.
But if you ask for too many permissions for that role, you're going to lose the customer. You're not going to get the permissions you want. People review the whole cloud formation with all the permissions you ask for, and they're extremely picky about it. So it sounded tempting to just ask to access everything. This one doesn't work.
So I've seen one approach out there where essentially you ask for two accounts, right? So there is an account that you use to do the initial deployment, which has a wide set of permissions. And then after your initial deployment is done, then the customer would actually take access away from that account and give you a more limited account that lets you look at, say, observability data or just look at what is running as a view-only kind of account. And if there is a problem or they need to help debugging something, then they can switch the higher capability account back on. So that gives them a bit more control. It gives them auditability, also saying, okay, we gave this account at this time and then we revoked it, right? So we know that after that window of debugging, then they won't be able to access it anymore. So that's one approach I'm looking at. But if you have better ideas, I'm all ears, right?
Yeah. No, unfortunately I don't, but it does sound like a good idea. So I hope everyone in the community, someone will try it and will tell us how it went.
Yeah.
Or you can come back later to tell us how it went.
I've seen a couple of products already out there that use this approach, but I haven't seen a lot of feedback about their success around it.
It's also early, right? Like we're all making a bet. And honestly, we're early and our customers are making a bet using us. So it kind of goes in circles. You mentioned earlier moving from Calico to Cillium. I am very far from being a Kubernetes networking expert. I know just enough to know that there are a lot of issues that I may run into and I don't know how to solve. Can you share a bit about what made you switch and then maybe some downsides that you didn't expect in Cillium before you moved, kind of thing?
So the switch was actually more of, as we grew our platform, we learned various things. So when we started out with this platform, it started out Like you can think of it as very monolithic. Everything was in a single cluster. You know, there was no separation between where the data plane was and where the customer stuff was running versus where we were with the control plane. And that worked out. Single cluster, everything is there, but then you can't scale. So then, okay, so we have to split out the two clusters. We have our metadata and control plane running in one place, data plane running in the other. But we need to communicate between the two of them. And the simple solution, okay, just starting out, we just went gRPC and everything is synchronous communication, right? Easy to do, hard to debug, right? When stuff goes wrong with the network, synchronous communication doesn't work as well, but we can start there. And since we needed secure communication across the two sides, we were using Istio to essentially create a mesh across the two so that control plane, data plane can talk to each other. Simple. And as you grow with the product, that doesn't quite cut it. So now we end up with cases where we need BYOC and we need true isolation of the data plane from the control plane. So there can be no incoming calls from the control plane to the data plane, right? We can't have bidirectional communication anymore. So then Istio is not as useful because that kind of relies on pretty close ties between the two sides. So now that Istio is not useful, we still need secure communication, right? And we can do that in AWS, they have a concept of a private link that you can set up. So that gives you a secure tunnel between the two sides and limited as to what service can talk to what, which is good. Right. And
it's probably the most useful thing AWS came up with for running infrastructure.
And it initiates from the data plane side, controlling to the control plane. So now you know that your network traffic is also going in a particular direction. And as we went to this, we realized that we didn't really need Istio in particular anymore. We still wanted to have encrypted communication. Everything needs to be secure. And we started looking at Cillium. Cillium actually has built-in encryption between the pods, and it makes sure that its network policies can be written so that you can actually identify your two workloads and make sure that your policies can isolate who can talk to whom, right? So that then eroded some of the value that Istio gave us. The Cillium network policies also let you do stuff like DNS-based policies, better egress and ingress policies. Exactly. And Calico has some of this capability, but I think it was on a different tier, like an enterprise tier or something like that. So, as a startup, you have to watch your cost. Cillium, I think, provided a good place to be. So it gave us the ability to secure our traffic, to have good network policies. It actually removed the sidecars that were running everywhere when we were running Istio.
You got some percentage of your CPU back.
Right, we got CPU and memory back. It's got some nice tools around actually monitoring the network flow and looking at what traffic.
What built into the networking layer?
Yeah. Yeah,
so I don't need the whole sidecar with eBPF to watch network traffic kind of stuff anymore?
So it will give you information about, okay, this service tried to connect to this service and the traffic was either accepted or rejected because of network policy, right? And then you have to go from there and look at what policy.
Yeah, so it's basically application tier plugins that you can, the kind of stuff that you.
You don't need the application tier stuff in order to watch what's happening and to debug your policies. So given all this, it actually was relatively easy to move to Cillium. There were some gotchas. Right? There's always some gotchas, and you have to tune your installation to work with what you're trying to build. We can have lots and lots of Flink clusters running, which leads to a lot of network policies being set up. And this is another place where Calico versus Cillium was good because Calico is all IP tables based. Cillium is eBPF based, so it scales a bit better with the policies. So,
Yeah.
Given all of that, I think it was a good move to swap that layer over. But
definitely, can you give
both
us
of them.
A sense, like how many policies is a lot of policies? Like what kind of numbers are we talking about?
So essentially, for each. So the number of policies is not as much. Right? There's like 2 policies on each particular Flink cluster, but we have a lot of rules within the policies.
Okay.
Right, because we have to identify exactly the places
10,
it can talk to.
100, 500?
Depends on the query. Right, so if your query is talking to a bunch of different stores, then we have to identify each of those places that it can talk to.
That's right. And also it depends on the customer, right? Because you're basically taking their RBAC rules and pushing them
and
down.
Applying them. Yeah.
Ooh, interesting.
So it's variable.
Do you
For the
know if there's
simplest,
like a scale limit? Do you tell your customers don't create any more than N rules or our Kubernetes will blow up?
Not really. No, we don't. We haven't run into that limit yet. I'm sure it's there, right?
One day,
the thing about
the
thing about SaaS is it doesn't solve all your problems. Right? So and serverless, there are actually servers in the back. There's nothing actually serverless.
We kind of knew that.
So serverless works really well as long as you stay within the constraints set up by the system. So there are constraints on serverless, and we have those defined. So as long as you stay within those constraints, and your product works, then it fits you. If you need to do something beyond that, then it doesn't. Right? Even MSK, like if you look at the serverless MSK, which is AWS's Kafka product, they will say you can run serverless as long as you're not going over a certain number of partitions, a certain number of topics, right? Because
absolutely. So I have a confession to make. Personally, my new startup does not use Kubernetes yet. We had Kubernetes in the past. We had some really good experiences, some slightly meh experiences, some absolute disasters. I think anyone without your extremely wide experience will have a lot of learning moments, let's put it. But we know it's coming. We know that we are reaching the limits of complexities that make sense for us to still manually handle with various tools. Do you have like some top tips other than the tools you already suggested we'll get into? Like, hey, as you resume your Kubernetes journey, it's been a while. Here are some advice and things that you may not have known.
Again, this is very subjective, right? So it depends on what you are building. A lot of times, Kubernetes is probably not what you want. Right? It's a lot of management overhead. So if you're running like, I don't know, 3 or 4 microservices, maybe you don't need Kubernetes. That's overkill. It's too heavy for what you want. And in those cases, I think all the clouds basically have their own container orchestration systems, and that's usually enough. Right? It's the equivalent of running 4 or 5 Docker containers. And if you're running within the cloud's container system, you can actually scale out each of those containers. They'll let you do that. Kubernetes really becomes interesting when you don't know what you're going to launch yet. Right? So think of like in our case, we have to launch Flink clusters, but it only comes about when some customer actually requests us to run a query. Right. And now you can have interesting things like you can build your operator or use an open source operator to actually run this workload for you. Cases where you can predefine what you want to run, you could probably run in something simpler. Like if
Yeah, so something that I thought is a good use case for Kubernetes. Tell me if I'm right or wrong. If you're running systems that talk in a protocol other than HTTP, I feel like a lot of the cloud autoscalers, ECS, container services, They're really nice as long as your health check is an HTTP endpoint, as long as your failover is basically just you start directing traffic over there.
Right.
Like there's things for systems where it doesn't work, where you need to do stuff like shoot the other node in the head, quarantine different things. It always felt like even Kubernetes didn't always feel flexible enough for my needs,
Yeah.
but at
That's it.
the cloud API level, it was never there as far as I can.
That's kind of where the operators and stuff fit in, is where you have, I think, I forget the exact thing that was defined, but to me, operators are where you have DevOps knowledge that you need to put into an automated system. Right? That's I think the core use of an operator. So if you have knowledge, that's where you have all of these containers running, and you need to find the one that's misbehaving and get rid of it, or isolate that one and then slowly drain traffic. Things where the simplified things that the cloud systems provide, the cloud container services provide, don't really do it for you. That's where I would write an operator and put my knowledge in there so that I, where you can
or in
do
your
software.
case, put Hojat's knowledge into the.
Exactly.
Yeah, I think that's why your operator is such a strong abstraction, because again, like the combination of someone who really knows what you can do and how to do it with Kubernetes, which usually Flink people kind of lack, they're trying, but how much can you actually learn about two very complex distributed systems? And then you have
Right.
someone who knows, as you said, like how to detect that the Flink node is misbehaving, what is the right way to actually get rid of it without causing a huge incident, restoring the current state when you start a new one, all those things. So like the combination of really strong domain knowledge and really strong platform knowledge is just the secret ingredient, I would say.
Yeah, no, that's way I'd put it as well. So
amazing. Krishna, thank you so much for telling us and sharing some advice and a bit of your secret sauce with the
absolutely.
community. It's so useful.
It was good talking with you, Gwen. Thanks.